To simplify this, we're trying to find perfect cubes, and it turns out that the cube root of 27 times 4 is 108. The cube root of 27 is 3. The cube root of 4 cannot be simplified. So this is 3 cube root 4. We need to split this apart. So this is going to be root 2 divided by root 5. But to simplify, you're always going to have no roots in the bottom. So we're going to rationalize. On top, we end up with root 10. On bottom, we end up with 5. We cannot divide here because these are not like terms. 5 doesn't have a root. So the final answer is root 10 divided by 5. When we multiply, we can multiply the coefficients. So negative 2 times negative 5. And then the roots. So 2 times 15. So this becomes positive 10 times 150. And then 150 is 25 times 6. So we have 10 times root 25 is 5. And then root 6 we can't do anything with. 10 times 5 is 50, and then root 6. You need to be careful here because we need to distribute. We have 5 times 1 plus 5 times root 6, and then negative 3 times 1, negative root 3, and then times 1, and then negative root 3 times 6, so we can combine that under one radical. 5 times 1 is 5. Negative 3 times root 3 times 1 is just negative root 3. And then this becomes negative root 18. So we have 5 plus 5 root 6 minus root 3 minus root 9 times 2. And this becomes 3 root 2. So we have a root 6, a root, oh, we do have a root 3 here. Oh, no, this is a root 2. Gosh darn, I keep doing that. Root 2 left over. So we have a root 3, root 2, root 6, and a 5. We have no like terms, you guys. There's going to be 4 terms here. 5 plus 5 root 6 minus root 3 minus 3 root 2. The order doesn't matter, but make sure this is positive, this is negative, this is negative. We, as written, there's nothing we can simplify here, but if we reduce, then we have something to work with. So we have 3 root 98 is actually 49 times 2. Root 7 we cannot simplify, but root 28 is 4 times 7. So this becomes 3 root 49 is 7. We can't do anything with that root 2. Can't do anything with the root 7. Root 4 is a positive 2, root 7 stays. This becomes 21 root 2. We have a negative 1 root 7 term and a positive 2 root 7 term. So the root 7 stays, but negative 1 plus 2 is positive 1. So our final answer is 21 root 2 plus root 7. Notice I dropped the 1 here because 1 times root 7 is just root 7. If we're looking for sine of A, we need to do the opposite side. So here's my opposite from A. And then this is the hypotenuse. But we don't know the hypotenuse, so we need to do Pythagorean theorem. So I need to take my 2 legs and square them. 4 squared plus 4 root 2 quantity squared equals the hypotenuse squared. 4 squared is 16 plus, we have to do both of these. 4 squared and root 2 squared equals the hypotenuse squared. So this is 16 plus 16 times 2 equals the hypotenuse squared. And then that's 16 plus 32. And that's going to be 48. Take the square root of both. This is 16 times 3. So we get 4 root 3 is the hypotenuse. Okay? But we want to find sine of A. So sine of A is opposite over hypotenuse. Opposite side is 4 root 2. And we're going to divide that by the hypotenuse, which is 4 root 3. So the 4's cancel out, but see the 2 over root 3? We now have to rationalize. It just is the problem that keeps going. Root 2 times root 3 is going to be root 6, and root 3 times root 3 is divided by 3. Because this doesn't have a root, it can't simplify.